1 week. 7 days between ordinary life and a strange quiet where maps don't load, flights can't find themselves, and the world's backbone hums out of tune. This is not a doomsday fantasy. It's what a severe solar storm could do to a planet that runs on electricity, timing, and fiber. It starts with the sun coughing, a magnetic knot tearing free, and ends with all of us learning how fragile online really is. Day 0 begins with light. Not the gentle kind, but a spike in X-rays and ultraviolet from a powerful solar flare erupting near the center of the sun's face. Space weather forecasters watch a loop of magnetized plasma snap and fling an enormous bubble into space. A coronal mass ejection, or CME, billions of tons of charged gas, threaded with magnetic fields, expanding like a storm front. They know the geometry is bad. The launch is almost dead-on toward Earth, and the ejected magnetic field looks twisted in a way that can latch onto our planet's field when it arrives. The first warning, the flare's radiation, reaches Earth in 8 minutes. Radio fades ripple around the daylight side. Shortwave bands go noisy. High-frequency communications blink and return. The real problem is still en route, a cloud that moves slower than light, but fast for a thing the size of planets. 18 to 36 hours out, the numbers say. Enough time to send alerts, not enough time to rebuild anything. Day 1 arrives as a pressure wave in space. Satellites upstream feel the solar wind surge. Instruments register density spikes, temperature jumps, and a magnetic field turning southward relative to Earth's north, exactly the orientation that unlocks our magnetosphere. When that south-pointing field hits, it opens a door. Energy pours into the magnetotail, then snaps back toward the poles. Currents race through the upper atmosphere. Aurora ignite far from home, curtains of green and crimson unfurling over places that haven't seen them in centuries. On the ground, this is beautiful, but it is also physics with teeth. Those upper atmosphere currents induce counterparts in anything long and conductive below: transmission lines, railways, pipelines, the metallic bones of modernity. Grid operators see their reactive power margins shrink as transformers begin to saturate. Protective relays, sensing distortions, trip lines to save equipment. Lights flicker. Regions blink. The internet, which is not a cloud but a web of specific machines tied together by power and time, feels those blinks as packet loss and unexplained resets. Satellites feel it differently. In low Earth orbit, the upper atmosphere puffs as it heats, swelling like a tide. Drag increases. Orbits decay. Space debris and fresh satellites alike encounter denser air than expected. Some attitude controls fight to keep solar panels pointed, others enter safe mode. During a solar storm in 2022, dozens of new satellites deorbited early for exactly this reason. Higher up, at geosynchronous orbit, spacecraft ride out a hail of energetic particles that charge surfaces and see pinto electronics. Well-designed birds can take a beating, but a few suffer glitches, bit flips, or temporary blindness. GNSS constellations, the satellites that feed GPS, Galileo, Beidou, GLONASS, still broadcast, but the ionosphere below them, the electrically active shell that radio signals must cross, has turned turbulent. Positioning grows noisy. Timing wobbles. Every system that relies on those nanosecond pulses discovers what it means to be a few microseconds late. Day 2 is a lesson in what down really means. Power grids, especially those draped across high latitudes, are still juggling induced currents. Operators reroute loads, split networks, and lean on thermal plants to provide stiff voltage support while they nurse transformers through saturation. In some places it works. In others, protective devices trip to prevent permanent damage. A blackout is a controlled fall compared to a burned transformer, because the latter takes months to replace. As load sheds and islands, data centers on the edge of those grids ride on UPS batteries and diesel generators. Most have hours, some have days. Fuel contracts that looked academic are suddenly real. The arteries of the internet, the long-haul routes and exchange points, honor the outages by rerouting traffic. It works until it doesn't. The map reshapes, paths grow longer. Congestion builds in places that were never meant to carry the world. Undersea, the glass itself is fine. Optical fiber doesn't care about space weather. But the repeaters that dot transoceanic cables every 50 to 100 kilometers get their power from high-voltage direct current pumped in from the landings. Geomagnetically induced currents can ride those long conductors, skewing voltages and tripping protection. Some cables hiccup and restart. Others take segments offline while engineers rebalance supplies. Packets that used to skip across the Atlantic in an eye blink now take detours that crisscross continents before catching a working bridge. Latency spikes. Video calls stutter. Streaming services fail over to lower bit rates and then to apology screens. It's not that the internet is down, it's that 1,000 independent dependencies are failing at the same time. Air travel discovers how much it depends on invisible patterns. Polar routes, popular for shaving time off intercontinental flights, pass through regions where high-frequency radio either back up when satellites are jammed or asleep. In a storm, HF goes dark or chatters unpredictably. Airlines reroute south. The auroral ovals expand, waypoints vanish. Controllers stretch to handle corridors outside normal flows. Precision approaches that lean on space-based augmentation systems revert to ground nav aids that many pilots haven't used in years. It is safe, it is slower. Airports become bottlenecks for reasons that have nothing to do with weather on the ground. Day 3 introduces a quieter failure: time. Modern networks are choreography. Banks settle trades in windows defined to the microsecond. Stock exchanges use synchronized clocks to order events. Cell towers hand calls to neighbors based on tight timing. Cloud databases keep replicas aligned. All of that works because they share a common time base, usually disciplined by GPS or its siblings, with local oscillators that free run for a while if the sky goes weird. A day into a storm, the free run begins to show. A few nanoseconds of drift become microseconds. Microseconds become milliseconds. Logs go out of order. Consensus protocols that assume bounded delay start to frown. Most systems are built to degrade gracefully. Some aren't. A factory floor drops into manual mode because its wireless timing broke. A financial venue pauses trading to avoid disputes about order. Emergency services revert to older playbooks when their networks fail to agree on who spoke first. None of this is catastrophic alone. Together it is friction everywhere. Phones still work until they don't. Cellular networks are small grids perched on big ones. When the big grid stumbles, the small one lives on batteries. Urban towers last a few hours. Rural ones, designed for storms and long repair times, might last longer. Carriers prioritize 911 traffic, but in some regions, overloaded cells shed users. Messaging apps fall back to text and then to nothing. People learn which hill gets a bar and which window points the right way. The world does not go quiet. It gets local. Day 4 is when logistics reveal their dependencies. Ports that lost cranes to power cuts now wait for generators and fuel. Ships hold outside harbors because AIS displays are jittery and harbor pilots are conservative. Long-haul trucks, which rely on electronic logging and routing with timing discipline, plod with caution. Refueling is slow where gas stations depend on credit networks and pumps need power. Supermarkets that were replenishing daily discover what just-in-time means when the time is wrong. Nothing has failed in the way a broken bridge fails. Instead, everything is late, and that makes other things later. Hospitals are islands built for this, but islands still need supplies. Ventilators and monitors run, operating rooms continue, generators thrum, pharmacists count their inventory with more care. Clinical labs that send samples to centralized facilities for next-hour results see those results drift toward next day. Radiology modalities that upload to cloud readers batch and retry when the pipes open. It is safe because people make it safe. But the workload moves from machines to humans with clipboards who know how to bridge a gap. In orbit, ground controllers have been busy. Spacecraft that can be turned away from the storm have been. Those with sensitive instruments are in safe mode. Operators of large constellations tweak drag models and watch conjunction warnings multiply as orbits decay unevenly. The sky has always been crowded, now it is dynamic. Insurance suddenly includes clauses everyone meant to read. The sun does not aim, it simply breathes, and everything down the line must adjust. Day 5 is the pivot from crisis to procedure. Space weather calms in waves. The CME's main body passes, the tail lingers. Geomagnetic indices relax. Fields quiet. Power operators reconnect islands carefully. Transformers that took the brunt get thermal scans and oil samples to check for internal heating. Some are retired, eerily out of caution. The black art of black start, rebooting a grid from cold, comes off the shelf in places that lost everything, synchronizing small power plants to bootstrap bigger ones. It is choreography in a minor key. Restore enough to stabilize hospitals and water plants, then expand, then bring big industrial loads back gradually to avoid another trip. In parallel, internet exchange points hum back to normal as cables and landing stations resume nominal power, and submarine repeaters settle into their DC rails. Engineers who designed the backbone services everyone forgot to thank get busy with the post-mortem while thelogs are still fresh. Anycast networks that steer users to the nearest healthy server analyze how their routing responded when nearest changed under their feet. CDNs that cache the world's videos compare how their tiers drained when long-haul broke. DNS resolvers that hid outages for hours via cached answers decide whether to shorten or lengthen those caches next time. The fixes are not cinematic. They are defaults, thresholds, and circuit breakers set a touch earlier or later than before. Day 6 looks like recovery on the surface and like homework underneath. Airlines revert to polar routes as HF steadies and ionospheric turbulence calms. Satellite operators pull instruments out of safe mode and recalibrate. The ionosphere's structure, shaken, begins to settle. Geophysicists comb magnetometer records and induced current sensors on pipelines to map where the Earth's crust let the most power flow. It will inform which substations get upgrades next. Meter readers find surprises, stray currents that corroded valves and welds more than expected, a known side effect of geomagnetic storms. Maintenance crews swap parts that worked but aged years in a day. The final day is a mirror. Life resumes what looks like normal, but millions of people have learned how invisible the supporting physics was. You can unplug a server and be fine. You cannot unplug the sun. The difference between a dramatic loss and a controlled inconvenience was planning at scale, boring redundancy, practice drills, a bias toward graceful failure. The internet never turned off. Many of its roads did, and detours existed because someone built them long before the traffic came. There's a deeper science story embedded in this week. The sun is not malignant. It is a magnetic machine. Loops of field boil up, twist, store energy, and sometimes snap. The particles a flare hurls are fast, but their X-ray light is faster still, giving minutes of warning for radio fades. The CME is slower, and its danger lies not in how hard it hits, but in how its field lines point. South-pointing fields reconnect with Earth's north. North-pointing fields glance off. We cannot change the sun. We can measure upstream with satellites parked at L1, a point in space where gravity and motion balance, and use those measurements to set humans and machines on the right footing. We already do. The question is whether we take our own advice seriously when the quiet years lull us. History gives bookends for what this week could be. In 1859, the Carrington Event lit telegraph offices on fire and painted auroras over the Caribbean. Telegraph wires, long ungrounded conductors strung across continents, acted as antennas for the storm. Operators found they could send messages with their batteries disconnected. In 1989, a smaller storm tripped the Quebec grid in 92 seconds. Transformer cores saturated. Protective relays did their job. The network fell to prevent damage. Millions sat in the dark for 9 hours. We have more sensors and better models now. We also have longer lines and tighter tolerances, and we depend on timing in ways our ancestors did not. The risk isn't that the past repeats exactly. It's that variations on familiar themes cascade through a different kind of society. Preparedness is not romantic, but it's what changes a story. Power engineers can design transformers with better tolerance to DC bias and install series capacitors to block induced currents on long lines. Substation grounds can be improved, so induced voltages bleed into the earth instead of equipment. Grid control rooms can run storm playbooks, reduce long-distance transfers, bring extra reactive power online, staff up, split networks into islands before the storm does it for them. Telecom operators can diversify timing sources beyond GNSS, build more atomic clocks on site, use terrestrial time feeds, cross-check multiple satellite systems, and monitor the ionosphere in real time. Data centers can test their generators under load and their diesel supply chains under stress. Airlines can keep polar reroutes fresh in muscle memory. Ports can rehearse manual modes. Individuals do not harden transformers, but they sit on the edge of these choices. A week like this runs smoother if homes and offices know which communications still work when the newest ones don't. Battery radios, not for nostalgia, but because physics favors long wavelengths when the ionosphere is noisy. Printed maps for the rare moment maps don't load. Cash, not because banks fail, but because point-of-sale terminals do. Medications on hand because logistics is all timing. It reads like an emergency kit for a storm with no clouds, because that's what a space weather storm is. There is also beauty in the danger. The same physics that stresses a transformer paints Aurora in colors that make people cry. The same sun that threatens satellites also powers the heliosphere, the protective bubble deflecting cosmic rays from the outer galaxy. We live in a magnetic dialogue with a star. The price of that protection is a temper you can forecast but not mute. A week like this would leave photographs no one could have planned, and lab data geophysicists would mine for decades. The last lesson is conceptual. We talk about the internet as if it were one thing because it feels like one thing when it works. It isn't. It is a federation of networks that agree on a few simple protocols. Redundancy is not a luxury, It is the architecture. When enough independent parts are after the same goal, keep moving bits, grace emerges. During this week it did. Routes elongated, caches served what they had, resolvers remembered what they could, and the rest slowed gracefully towards zero rather than trying to sprint and falling on their faces. That resilience did not arrive by accident. It was designed by people who assumed the worst and were right. The week the sun turns off the internet is a shorthand. The sun doesn't turn us off. It tests which parts we were kidding about. The outcome is not set by the flare, but by the preparation. Forecasters who watch magnetograms and coronagraphs, controllers who understand their substations like pilots understand cockpits, network engineers who can read a BGP table the way a farmer reads a sky, pilots and dispatchers who can route around a blank map. All of them decide how loud the storm feels. When the indices fall and the aurora retreat to their usual latitudes, people will scroll again and forget. But some things won't be the same. A transformer replaced early is not glamorous, but it is a sentence that begins next time. A ground strap installed on a pipeline ends a footnote about corrosion. An airline SOP rewritten to include a storm checklist in the same binder as de-icing and bird strikes closes a loop. A data center buys another rubidium clock and sleeps better. A family keeps a radio because they like the strange comfort of hearing voices when the rest was glass. 1 week is enough to show how everything is connected, and enough to show how much slack there still is if we care to keep it. The sun will cough again. It always has. Between now and then are choices that turn a headline into a story we tell with relief instead of regret. That is not fear talking. It is physics quietly asking whether we listened.